Equations with variables on both sides. If you look at this example, x minus 6 equal 3x. We have a variable on the left side as well as variable on the right-hand side, right? And they're both x. These two variables, they want to be together. We need to combine them, right? They always want to be combined. The x on the left side is smaller. So what we usually do, we'll take the smaller x and move it to the bigger x. Basically, the positive 3 says, hey, you smaller one, you come over here. I'm not going over there. So the x wants to become a 0 on that left side of the equal sign. And the only way to make the positive x to be a 0 is by subtracting the x. What we do on one side of the equal sign, we have to do on the other side of the equal sign, right? It's an equation. X minus x indeed does equal to 0. We have the minus 6 there, right? Or a negative 6 at this point, equals, and 3x minus x is 2x. Now we're solving for x, so we're going to put it in a bubble. We're going to kind of isolate it. And that 2x wants to become 1x. I just want to know what 1x is, not 2x. To make 2 to be 1, I have to divide it by itself. What I do on one side, I do on the other side of the equal sign. And negative 6 divided by positive 2 is negative 3 equals, don't forget to drop that equal sign. 2 divided by 2 is 1, and it's a 1x. So our solution is negative 3 equals x. Now, what do we always do? We want to make sure that indeed we are correct. So we're going to do a little check. We're going to rewrite the original equation, which said x minus 6 equals 3x. Now what we said, that every x I see is negative 3. So we will substitute in the negative 3 for every x in the original equation. We have x minus 6. So now it is negative 3 minus 6, right? And that is supposed to equal to 3 times x or 3 times a negative 3, because x, remember, is negative 3. That's what we said. Well, let's see if both of our equal sign equations, well, both sides of the equal sign are equal. Well, negative 3 minus 6 is negative 9. 3 times negative 3 is also negative 9, and it checks. So negative 9 equals negative 9. We are good. Let's look at the next example. Our next example says 2c, or 2 times c, plus 3 equal 5c minus 9. What do we want to do? We want to make sure we combine our variables first. So the 2c wants to be with the 5c. And as we said, the smaller variable gets moved inside the bigger one. The smaller variable is on the left side, right? And it wants to be gone from the left. It wants to become a 0, right? It doesn't want to be there. So we're going to take it and we're going to move it. How do we move positive 2c? Well, by subtracting the 2c, right? That's the only way to get a 0. What I do on one side of the equal sign, I'll do on the other side of the equal sign, right? It's an equation, keep it in balance. Now let's make sure we're right. 2c minus 2c indeed is equal to 0, right? Same number, opposite signs, they will become a 0. And we have our positive 3 still. We still have our equal sign. Do not forget to drop down the equal sign. Now 5c minus 2c is 3c, and we have a minus 9. Do we have to write the 0? We do not, right? We know that 0 plus 3 indeed equals 3. So let's kind of fix it up. And we have 3 equals 3c minus 9. Let's see. Well, I know I'm solving for c, right? And I want to combine that positive 3 with the minus 9. And c says, hey, I want to be left alone. I want to be isolated, right? Well, we have to get rid of the minus 9 and move it to the other side because it wants to go away from the c. Well, minus 9 wants to become a 0. The only way to make a minus 9 a 0 is to add 9 to it, right? We basically always do the opposite of what we see the second we're switching sides. So we're going to add 9 to both sides. Now we have 3 plus 9, which equals 12. Now don't forget, we have our equal sign, and that equals to 3c. Now I'm still solving for c. I want 1c, not 3c. So what do? That 3 has to become 1. And the only way to make a number or anything equal to 1 is to divide it by itself. So if I isolate my c, I want it to be 1. I'm going to divide by 3. What I do on one side of the equal sign, I do on the other side of the equal sign. Now 12 divided by 3 equals to 4, right? We drop down the equal sign. 3 divided by 3 is 1, and it is 1c. And we solve this problem. 4 equals c, or c equals 4, same thing. Now let's make sure we are correct. Let's rewrite the original problem, which we have 2c, or 2 times c, plus 3 equal 5c minus 9. And we have said when we solve this problem that c is equal to 4. Well, let's make sure we are correct. Every c is going to get replaced with the positive 4, so we're substituting in. So 2 times 4, which was 2 times c, plus 3 equal 5 times c, which is 5 times 4, minus 9. Now we have to think about order of operations. We have multiplications, additions in there. Well, order of operations says do the multiplication first. 2 times 4 is 8, plus 3 equals to 5 times 4 is 20, minus 9. What is 8 plus 3? That's 11, equals 20 minus 9 is also 11. So guess what? Both sides of the equal sign are equal, so our solution checked. Yay! Let's look at the next example, what we've got. We have our parenthesis in there. Remember the number before the parenthesis. If you don't see anything between the number and the parenthesis, that means it's a multiplication. The 4 is multiplying everything inside the parentheses. Multiplication is a ninja, all right? So if you don't see it, it's there. So let's take the 4 and let's distribute it. The 4 is going to multiply x, and the 4 is going to multiply the 2 using distributive property. 4 times x is 4x. 4 times 2 is positive 8, which equals to 2x plus 8. Now we said, combine, combine, combine. Well, we will combine our variables first. Always do that. So the 4x wants to be with the 2x. And the smaller is going to make that move, right? The 4x is going to say, hey, you 2x, you come over here. You're smaller. You come to me. All right, well, that 2x is on the right-hand side. And that 2x says, all right, well, I come to you because I want to be over here, 0. I don't want to be here. I want to be with you. Well, positive 2x, to make it a 0, I have to subtract the 2x. Equation has to be equal on both sides, right? What I do here, I do over there. So subtract 2x from both sides. What are we left with? 4x minus 2x is equal to 2x. We still have our plus 8, have our equal sign, and 2x minus 2x, woo, it's a 0. Same number, opposite signs, right? It'll become a 0. plus 8 is still there. Now we are solving for the x, right? The x wants to be there alone. Now the 1/8 wants to be with the other 8, right? So we have to somehow combine these two because the number 2 is attached to the x by multiplication. Now let's combine the two 8s first. When we are undoing these guys, we have to work our order of operations backwards. Basically, PEMDAS going back up, right? So we have to undo the addition first. The positive 8 that's attached to the 2x wants to become a 0. It wants to be gone from the x. So the one way to make it is -8. What we do on one side, we'll do on the other side of the equal sign, right? -8 minus 8. The 2x we did not touch yet. It's still in there. Plus 8 minus 8, that is a 0, right? So the 8 is gone from the left side. It moved to the other side. We have our equal sign, and positive 8 minus 8 is also a 0. Now we have 2 times x equals a 0. Well, I don't want to know what 2x is. I want to know what 1x is, right? So the 2 has to become 1. So I'm going to divide it by itself. Both sides, right? Equation. 2 divided by 2 is 1. So we're left with 1x equals 0 divided by 2 is a 0. So we're saying that x is equal to 0. What we're going to do, we are going to make sure we are right. So we're going to do a little check. We're going to rewrite the original equation that said 4 times, in parentheses, we have x plus 2. That's supposed to equal to the other side, which says 2x plus 8. We have solved for the x. We said that x is equal to 0. Well, let's make sure we are right. So we're going to substitute. Every x we see will be replaced, will be substituted with 0. So 4 times, parentheses, 0 plus 2 equals 2 times 0 plus 8. Order of operations. We want to make sure we take care of our parentheses first, right? PEMDAS. So let's take care of it. What is 0 plus 2? That is 2. So 4 times 2, supposed to equal to 2 times 0 is a 0 plus 8. Now what is 4 times 2? Which is 8. And that equals, on the other side, we'll just have the 8. So we have solved this problem, and both sides of the equal sign are identical, so it does equal to each other. We're good.